Hello, let's continue our Sudoku adventure with this very nice puzzle, Convergence by Riffclown. So, what are the rules? Well, we have irregular Sudoku rules. So in every row, column, and bolded region, we are placing the digits 1 to 6 exactly once each. So instead of our normal boxes, although we do have 2 of our normal boxes, we have these irregularly shaped regions, like these L-shaped regions, for example. There are still 6 of them, and there are still 6 cells each. So work basically the same, but there might be some interesting geometry in this puzzle that utilizes the irregular rules. Additionally, we do have standard arrows, so digits along an arrow sum to the value in the circle. You can repeat the digits as long as normal Sudoku rules would allow you to. So if these both could be 2, and this would be a 4, and that would be perfectly fine. Hopefully it's clear how these ones work. For example, this one, just these 2 are the same digit because it's a 1-cell arrow. And then this cell is just shared between both of these arrows. All right, so those are the rules. I guess I should mention that an arrow with multiple, a circle with multiple arrows coming out are separate arrows, right? These 2 add to this. This is the same as this, and these 2 add to this. You don't add up all of these cells, which probably wouldn't even be possible. So anyway, those are the rules. There's a link in the description if you'd like to try it yourself. Highly recommend you do. And I am going to get started right now. All right, so I want to start by looking at the geometry of these L's because that really stands out to me. I don't think any of these arrows really stand out other than the fact that these 2 are the same digit and these 2 are the same digit. But we can't really do a whole lot with that right now that I can see immediately. But we do have these L's. So I think the key thing to look at with irregulars is where are we kind of forcing digits to be the same? So like these 3 digits go here, but also these 2 digits go here. And like these 2 digits go here. So that feels pretty key. Yeah, so this 3, for example, does go down here. So one of these is 3. Then whatever goes here also ends up down here. Ah, so I can place a 3. So let's make this green, just so we have some way to reference it. So the green cell does need to go, for in this column, the green cell can't repeat in the region, right? So it's got to go down here, just like the 3. But we can't put green in its own cell, or this would have to be a 0, right? We can't put 0. Because this is going to be just strictly larger than this, so it can't be green. So green goes here. Green is not 3, so the 3 goes here. And so now this adds to 3, which we can only do with a 1-2 pair. So green is 1 or 2, and let's just make this purple, just so we can track the other 1-2. That's usually important. Maybe we end up not using it, but we'll see. Cool, so that feels like the opening. Now let's look at these, because it's exactly the same. So we can just give these colors. Now the problem is I don't know if they're the same as these. So it might be confusing, but we do know this goes here. These are the same. And then we know this goes in the circle. So, okay, I don't know exactly what to do with that yet, but let's use these 1-2 pairs first. So this is pretty restricted. This could be a 1. But then this can't be any bigger than 5. So this is 3, 4, or 5. Because it can't be 1 or 2. And so this is going to be 4, 5, or 6. This is 4, 5, or 6. But it sees the 6. Okay, so these can't be 6, which means this can't be 5. So the max I can put in here is a 2. Because 2 plus 3 is 5. If we did 2 plus 4, that would be 6. If I did 3 plus 3, that would be 6. Okay. So this is the purple 1-2. Nice. So we have more 1-2 pairs going on here. I'm just going to fill... Yeah. Where does 6 go in this row? It can't go on this arrow, so we can place a 6. I can now place a 6 in this row. I guess there's a 6 up here. I would not be surprised if it ended up in the circle. 6 is up here. Look, these 2 6s look up into this region. And so 6 is one of these 2, but we can't put 6 on an arrow or this would be too big. So that's a 6 and that's a 6. So 6 did end up here. Let's transfer that to here for our arrow. I'm done with 6s all of a sudden. So can we use this yet, or is this just not as helpful right now? Maybe not. I don't know. This is a 4-5 pair, which means this has to be 1 or 2. Because if it was a 3, we couldn't add to 6. So I don't know what color it is, but it's a 1 or 2. So then this is also 3 or 4. And it can't be 3. Oh, okay. Wait, can this be lower than 3? No, because it sees 1, 2, 3. And this can't exceed 4. So this is a 4. Yeah, nice. So this is 4 plus 1 is 5. These are all 5s. These add to 5, but we don't know how yet, because it'll be 4 plus 1 or 3 plus 2. Doesn't seem resolved. This is also 3 or 4, though. For the row, we do need to put the 4. So the 4 ends up here. So these end up both being 4 plus 1. We now have digits for our colors. We can clear that. Okay, so now that I have these colors, I might as well use them up here now. Whatever they end up being. All right, so this is a 4-5 pair. This region needs 1, 2, and 3. Okay, so the 3 goes here. That finishes the row. This is a 1, 2 pair. What is this? 3 and... Oh, 3 and 6. No, not 6. What am I missing? 2 and 3. Oh, so we know the order. 2 and 3. So this is 2 and 3. So that's a 1. Nice, we can clean all that up. This is a 2. Oops, not gray. This is a 2 and a 1. I think we're just finishing with Sudoku now. 4 and 5. Oh. Oh, I didn't finish this. Okay, so that's 5 and 4. And now we know where the 4 and 5 go. So a little worried about that. That's a 5. That's 4 and 5. Now I just need 1, 2, 3, and 4 in here. So where do those go? The 1 looks like it goes there. The 2 goes there. Then we got 3 and 4. Nice. Very cool puzzle, Riffclown. I liked the use of this irregular geometry to force certain cells to be the same. It was nice that this got used again near the end to just quickly place these digits. Not sure if we needed to, but that was fun. So cool puzzle. Thank you, Riffclown. And of course, if you enjoyed this puzzle, then why not leave a like, subscribe, and a kind comment below.